importing data. And all right, so you can see that it is in green actually, okay, light green. Okay, so it's not an instruction for the computer, it's not just note for you. Okay, importing data. And how do you import? Can you import data into this R? Okay, there are many ways. You can do it by using environment interface. Environment interface is actually here. Okay, let me introduce this console, these boxes first. Okay, we have 4. When you use RStudio, we have these 4 boxes. When you open up your RStudio, you have these 4. The first one is the code that you want to put in. Okay, remember that you can use, when you use R. Okay, let me open up R to do comparison. Okay, ini here you go. Let's use version 4 better. Okay, kalau kita buka R, you can see this R, right? I'm sharing you my screen so you can see it, right?
Yes.
Okay, thank you. So kalau kita buka R macam ni lah rupa dia. This is the R console. Alright, dekat sini lah kita nak bubuh function, apa-apa command. For example, I put in 2 plus 1. Alright, just one line or just very short instruction. So they give you the answer. 2 plus 1 is 3. Right? So whatever this is the R. Compared to the RStudio, is more convenient, all in one. The interface is all in one. The R does have that, but you have to, okay, source R code. You have to open up those windows or interface differently. They will have different interface for all this. But in RStudio, they compile everything in one interface. So easier for you, right? So this is for your code. This is for the console. Similar, this is the one that is similar with R when you open up R. Okay, for example, 2 plus 1, you get the answer 3. All right, 2 divided by 3. So it's just like a calculator, very easy. All right, but in this console, it will run your command by one line by one line, one instruction by one instruction. You put in instruction, you press enter, and then you run it. Put your instruction, press enter, and then you run it. Okay, this is the console. So it's not that I mean, if you want to run multiple multiple steps or multiple instruction, it's hard to do it this way. It's better to use this what they call this, just this project console, easier, right? So if you use the console or terminals console, okay, it is actually the R console where it will run your command line by line. If you have multiple instruction, it's better to use the project one because you can write there. You don't have to enter. You don't have to run it now. You just write whatever that you want to instruction of you want to the computer to analyze, and then run it maybe line by line, or you want to run it all at once, can be done. And you can do editing do editing. This is very important. The command is still there, and then you can modify whatever or do correction. Compared to this console, okay, you put in one instruction, and then you don't know if you have any mistake in there, whatever. So you just enter and then you get your answer. To modify that, no way, you cannot do that. You have to write back. All right, write back, and then okay, there's an error there. So what's wrong with my command? Then you have to modify that line by line. Okay, you cannot do like this one. This window, you can compile all the instruction. You can save it, put it there. They will be available here. So you can, if you want to do any correction or modification, you can just do it and then you can run it again. No problem with that. All right. So this is the environment. This is the environment windows. Environment windows means that when you run, you put in your data, you run your analysis, it will be mentioned here, it will be kept here. Means that it's actually like a memory, your RAM. This is the R RAM. When you put in the data, they will put in your data into this console, into this environment, they call it. Okay, you want, then you run ANOVA. You put it, they will put in the analysis into this window, into this RAM, or into this memory of R. Okay, so that is for later on. I'll show you what happened when we put in all the data. And another one is for your plots and graph. If you run to have to print a plot or graph, your graph will be displayed in this this window, right? So it is all in one compiler. This RStudio, it's actually R, but another programmer did very great work. They compile all the consoles, all the windows in one nice and easy software called RStudio. All right, so that's the basic of this RStudio, introduction of what is all these windows, right? So in this section, how can I want to no, I don't know how to increase the size of the font. Okay, so this is the importing data section for my codes. Okay, so you can import your data, put in your data into the brain of this R. First one, you can use environment. Here, this is the environment. Okay, look at this one. Import data set. You can easily import the data set. For example, you have Excel or from text file or from SPSS, SAS, or whatever, any other program. Okay, for your case, you are going to import it from your Excel data from practical 4, right? This data, practical 3. So this data, I believe that you did key in this data into Excel just previously. Okay, so okay, this is my data for question 1. Okay, so that is the data. I already put it in into my computer. All right, so diet 1, diet 2, so you have 2 columns, right? First column is for diet 1, second column is diet 2. Remember that columns are for variables, all right? For variables. So these are by rows, there are data in there, okay? And I save it. And the name of my data is, I put as data underscore P1 Q1, P4 Q1. So that is my whatever name that you want to put in. So when you call it in R, you have to be very, very specific. Okay, you have to put in the data underscore P4 Q1, so the R will recognize this. Or else, let's say you put in data big D A T A, and then R cannot recognize the file name. They must be completely similar or very identical, okay, on the file name, or else computer will not be able to find the file. So I have my file. What I can do is I just import it from here using, let's say, Excel, and then you locate where are your, you browse where are your data set are. Okay, just put it in. That's one way. Another way is that you can call it, okay, that this is my instruction. Okay, so before that, you have to put in, let's say you want to read the XLSX file, so you have to call or the R to have that capability of reading Excel file. So that is not by default. So call it. So the function, the code is library, means that you ask R to call for this library or this function. Okay, a library, and the name is read Excel, means that that is a function to read the Excel file. Okay, you don't have to memorize all this, but I want you to okay, let's say let me show you. This is the, I put my data in my computer. Okay, so this is the function. So first I put in the file name that I want to give for the data that I'm importing into R. Okay, for this question, so I put in data underscore Q1. It can be anything that you like. It can be anything except for you cannot give the name similar to the function code, default function code. For example, library, cannot use that as your file name, or maybe attach. All these blue colored words here is actually a default function code. Okay, like this library means that you want to call any other function in R. This attach, you are asking the R to attach this data. Okay, that is a default code. You cannot use that. So any other you can use just for file name. So maybe you want to put in soalan satu. So you give a label to this data. Soalan satu or data Q1, that is what I'm using. So make sure that it is in a single word. Means that I put in data underscore Q1. So Q1, as long as you understand what is that for, fine. For me, this Q1 is actually for question number 1, right? So data underscore Q1 and arrow sign. This is common. Arrow sign is actually equals to. So you give the file name equals to what are the file, where is the file that you are using actually. These are the function read underscore XLSX. So that the function, and then where is the location of this data? Is in my drive C, and the users mirror Google Drive is in the Google Drive actually. How are you going to know this location of the file that you want to? That is very long, right? To write that. So you just go to your Explorer. This is the data that I'm going to use. All right. Click, right click. You know this, right? You look at the property. There you go. This is the location of this file. You just copy that. Come on. Okay. Copy that. Just Control C. All right. Let me show you on on the text. Where is my here? What is this? Oh, no. Okay. Okay, that is what I've copied for the property. All right, and it's in the prac folder. You slash that. What is the file name? Blah blah. What this is actually data underscore P4Q1, right? Dot. What's the format of this? XLSX, right? That is the Excel code or Excel format. So this is what I've copied. Okay. Now, for R, okay, you remember that you look that the slash in here is backslash, right? Backslash, this one, backslash. But in R, it should be slash, like this one. See, what do you call this? I cannot remember the name. And then you slash, and then these are the location in users, folder users, Merok, and slash Google Drive slash. You just copy and paste whatever that you have copied just now, right? For example, like you put in data and the name, okay. The name of file, let's say I put in dummy1, okay, arrow dash. That is similar to equal. Okay, let's just, you can also use equal, no problem. And then
Doktor,
yeah.
nak tanya, macam mana kita nak tahu dia punya language?
Macam mana nak tahu dia punya language?
Macam ada apa-apa rujukan tak untuk kita orang masukkan kod dia nanti?
Saya tak.
Ada.
Ada buku untuk R ni, tapi saya tak ada buku lah kot. Nanti saya tengok. Sekejap Okay, saya ada satu beginner's guide to R. Nanti saya letak. Tapi ni pun dia kadang-kadang, sekejap kita tengok Dulu saya ada ambil masa buat PhD dulu, saya ada ambil kelas R ni sebenarnya. Because you are going to use just very simple code sebenarnya. Takut nanti it's too complicated and also hard for you to find things. Okay, jap. Kalau you perasan dekat your question paper, okay, kat belakang tu saya ada bubuh basic R command. Okay, in fact, you just follow this instruction. Library, you call this, and the data, and then bagi location. Just sama macam apa yang saya buat hari ni. Okay, so you just follow and try to use this code. Okay.
Okay, Doctor, thank you.
Okay. And the best or the easiest way, another one is that I always Google, because even an expert programmers, dia tak akan hafal ke semua function dalam any language. Tak akan hafal semua. Because benda ni ada je dalam buku manual dia, satu, ataupun ada dalam discussion dalam Google. So apa yang saya buat, selalunya saya akan, let's say, nak buat R pakai, nak buat ANOVA dalam R. Okay, contohnya okay, ANOVA. Yang paling senang kita pakai keyword dia lah, ANOVA test in R. Okay, nanti akan ada contoh-contoh. Ni ada step by step guide, one way ANOVA test in R, easy guide. So yang ini sangat membantu. Google is the easiest way of knowing things, yang especially benda yang kita tak tahu, tak pernah jumpa langsung sebelum ni kan. So dia bagi macam instruction, you just follow, try to understand how people do things and then apply. Okay, so saya faham situasi awak. Kalau yang tak pernah jumpa R ni, tak pernah pakai pun, memang macam apa benda ni semua kan. But you try to do it. I put in the instruction. It's actually step by step instruction here. Okay, so you follow and put in, and put in, and then I'm explaining in RStudio right now the things that I wrote in the question paper. Okay, so let's say, okay, contohnya saya bagi nama, kita kena panggil data. So data tu kita nak masukkan dalam R, we need to put a name for that. So now when you put in your data in R, give a name, because you will use that name later for your analysis. Katakan yang contohnya this one, I just put in dummy one. So I will use that name. You don't have to put in all the data again. Just call the name dummy one, whatever test that you want to do. Use that name because R already put in the data in their memory with the name. So you just call the name and I will understand that, okay, this name is for that data. So I will use this data to analyze blah, 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 blah. Okay. So yang ini ada arrow punya sign ni sama juga dengan same of the equals to. So let me try this, okay, to show you. Yang ini saya tukar jadi notes dulu. Okay, comment. Okay, sinilah. Oh shit. Once I put in this hashtag, all this line turn into green, right? Dia jadi Incredible Hulk. Okay, so yang maknanya saya deactivate that. So computer will not running that sentence. All right, so just I want to put in a new name, dummy1 read underscore XL. Okay, okay, bila kita put in the function, kadang-kadang dia akan keluar. So you just click and then no, silap. Okay, dia akan ada, kita suruh nak baca, okay, baca Excel file ni and then kita ada parenthesis. Okay, put in this parenthesis, put in the location of your file. Macam tadi ada copy and then daripada property of that file and just paste it, Control V, right? Paste, just make sure that you change the backslash to be slash. Sebab dia tak akan dapat baca R punya format, it should be slash, not backslash. But Windows, they use backslash. So tukar, apa nama file tadi? Data underscore Q1, is it? P4Q1 XLS set, right? And then dash. Oh, and then semicolon. Okay, you need to change all those backslash. Okay, change it into slash. Change it into slash. Okay, so mari kita cuba command ni jadi tak ataupun ada kesilapan. Okay, okay, let me try to letakkan satu silap dulu. Letak kat sini. Okay, then we run. How to run this? Just click here. This one, run. Zang, dapat ada error command here. Kan, error in this line, could not find function read SLSX. Oh, okay, betul lah memang. Sorry for that. Kita kena import dulu dia punya library, which is here. You have to put in all this code that I already put in your practical. Here, this one, run this first. Okay, so that you call the function to be able to read the Excel file. So you click this line and then you click run. Okay, so that they already put in the Excel as reader, and then run this line. Tak boleh. Error path does not exist. Kat sini, dekat console ni, you can see what's the problem. Dia tak boleh cari file ni. Why? So you have to check back. They are very specific. Check back, is this location correct? And what is this, the file name is correct? Blah, blah, blah. Oh, then I found one. Actually, yang ni tadi typo error. Contohnya, tak ada S dekat prac ni. Delete it. Alright, so run it again. On the same, when the cursor is on the same line, just click run. Okay, done. There is no error message. Means that the computer able to read this data. Alright, so that line is okay. So what's next? I want to attach the data. To attach the data to the system so that we don't have to call the file name every time. You don't have to call the file name every time when you attach it. Okay, what is your data actually? You want to see what is this data. You can also call that is your data. Or you can call the print. You ask the computer to print, or you can write it here also. Print. The name was dummy1, right? Print dummy1. Enter. So that is your data. You have diet 1, diet 2, blah, 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 blah. All right? So this is the data. If you don't attach it, you have to call diet, you have to call this data as, if, for example, you want to call diet 1 data, you have to put in dummy1, if I'm not mistaken, dummy1, and then in parentheses, diet 1. So when you attach the data, you don't have to do that again. It's very easy. You just call diet 1 or diet 2 straight away. So you attach that data. Okay. Later on, you find what is this function is doing. Just attach that. You run. Okay. Oh no. Error, object data Q1 is not found. Remember that I gave a new name for the data that I've uploaded. The name is dummy1, not data Q1. Data Q1 is the deactivated one, right? So let me clean up. Okay, you now let me just deactivate this, or maybe I just delete this. I want to use my original one. Okay, deactivate that, remove the, you see that when you put in hashtag, they are deactivated, all greens. When you remove that hashtag, now it's activated, it's black colors and mix of them, right? So I want to clear up this one. Okay, mula balik. So call for the library, call for the data, I attach the data, and then I print it. Just click the run. All right, print. So this is my data that I have. That is another way of importing your data. There is another way of doing that also. Okay, you do it manually. You can do that. So your data is not that much, very short data, small data. You can do it manually. But imagine if you have millions or maybe hundreds of thousands of lines of data. Okay, you are not going to do that manually, right? You just call, you save the data set with the file name, and then you just call. You use this function. You call the data, all right? Or maybe you just import the data set using this environment console. Okay, so this, but you can always do it manually if you want. If you have a considerably short data like this one. If you want to do it manually, okay, let me show you. You have diet 1, diet 2, right? Diet 1, diet 2. How to do that, to input that manually? Okay, let me clean this up again. So 0, tak ada data apa-apa langsung. So this is manual input. Let me activate this function. Okay. So now it's colored, right? So I give a name for that variables. For this case, I just follow the same. It can be any other. If you want to D1 or D2, it can be done as you like. Okay, tapi you have to put the name that you can understand and you can remember. So this diet 1 is for what data? This diet 2 for what data? Right? So if you want to do it manually, okay, let me show you. Let me show you the data. Right? All right, so this is the data. I just put it side by side so you can see that. All right. Okay, diet 1, this is data. So how? All right. Okay, this is the data in my Excel. How to put this manually? So you have to type that. So give the name for that column. Okay, diet 1. So I use the same diet 1. Arrow sign, or you can use equals to, as I said, right? If you want to use this arrow, yes, less than and dash. That is an arrow telling that, okay, diet 1, this is diet 1. So diet 1 is what? That is the data. Okay, you have to put in C, and then I always forgot about this name. Open parenthesis. Is it parenthesis? Betul kan? Kurungan parenthesis kan?
Yes.
Okay, thank you. Just checking korang ada lagi kat situ, because this is what you see in my screen is what I'm looking at now. I cannot see whether I'm in the class or not now. It's not, I'm not opening the Google Meet. Anyway, okay. So C is actually for column. You're telling the computer this data is actually a column, which is what you find in your Excel here, right? Diet 1. These are data for the column. So you see that you are actually typing your data in a line, right? 58.5, 57.2, 58.4 is in a line. So this is why you need to tell the computer that this is a column, man. This is a column. So that's why you need to put in C here. Telling the computer this data is actually in a column. It should be vertical, right? Column, and then type in your data. So you have 58.57.2, 58.4, and so on until at the end of the last one is 56, right? So let's see. Here you go, 56, and then close parenthesis and semicolon. So this semicolon is actually you're telling the computer stop here. All right. So this is the end of the instruction for this one, semicolon. Now then put in your next column, diet 2 equals, let's see, let's put it as equal here. It's the same thing. It also runs without any problem, right? And column and then blah blah blah. Type down your data here, right? Let's try it. Okay, now I've put in the data. Let's run. There you go. I already import the data for diet 2, diet 1, now diet 2. Import that, right? So what if you want to try it, you just then print. Print means that you call the data. You ask the R to print the data for you. You want it because you want to see is there anything wrong with the data. Okay, so you just diet 1. Yeah, there's your data. Print diet 2. You can choose. That is your data for diet 2. All right. That is if you want to put it in manually. Okay. So then now you have to check for normality, whether they are distributed normally or not. Okay, you can always Google. Let's say you want to test for normality, just use the keyword normality test for data in R. They will suggest a few. Okay, there's many of the tests for normality. I just use the Shapiro test, quite common one, Shapiro-Wilk command or test. You can use any. All right. So you call the name Shapiro.test. Okay, let's see. What if I just type? And there you go. This is actually a default command. So walaupun you type tak habis lagi, the keluar suggestion Shapiro test, right? You just click and then you can do that for you. And then which data that you want to test. Okay, let's say diet 1. Okay, so choose diet 1. You want to test the normality of this diet 1. Put in the semicolon. Okay, so okay, anyway, and then run it. So that is what you get when you run it. This is the output in the console. You run Shapiro test for diet 1, and what you get, the p-value is 0.3117. So means that they are normally distributed. There's no significant difference. The p-value is more than 0.05, means that they are normally distributed. How about diet 2? Okay, you click at the line there, anywhere on the line, and just click run. And also for diet 2 data is also normally distributed, no problem. So you want to see using plot, okay, QQ plot, quartile plot. Actually, you have to Google that. What is that QQ plot means? Okay, you want to see whether they are normally distributed or not. So just run it for these two, diet 1, diet 2. There you go. You get your graph there. Okay. Right. So for this QQ plot, it looks normal. There is no outliers. There is no a pattern of maybe it should be in a straight line. It is actually about 45 degree, right? That will be a perfect QQ plot. But for this data, it is acceptable because for this there is no you cannot see any outliers, you cannot see any pattern of this data distribution. Contohnya kalau dia macam melengkung, then something is not right, the data might not be suitable for analysis and so on. This is for your, before you run your statistical analysis, to make sure they are normally distributed. All right. And then they ask for one of the question, they ask for the variance equality. Again, you can always ask Google what are any other suggested tests for variance equality. So I choose Bartlett because last time for my PhD I used this Bartlett actually for to test the equality, variance equality. Remember that there's one assumption for t-test. They both have a similar variance. The variance are the same, right? So you have to test that. So I use Bartlett. Okay. Okay. What happened if I use this? If I run this command now, ta-da! You got an error there. Why? Because the data Q1 cannot be found. So because I already sweep out the data just now, and I put in manual diet 1 and diet 2, right? So clean this up again. I can, if I don't want to clean that up, yes, you can do that, no problem. So I just want to run it again, clean, run clean. Okay, so that's why I swipe it out. Okay. Okay. Now I test Bartlett. All right, there you go. When I run Bartlett, I get for homogeneity of variances, blah, 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 blah. Then the p-value is 0.4319. So it is not significant. Means that they have an equal variance. Okay, so then it passed all the assumptions, I mean, few of the assumptions, okay, with this test. So you can use the data for your test. All right. So we assume that both mean with equal variance, common variant equal is t. Okay. So you want to run a t-test. Just call the t-test. Okay, let me try to type this again so that you can see. Come on. Right, that's a function. Just when even you haven't finished typing it out, just choose the t-test and which data that you want to use. Okay, you want to use diet 1, comma, and diet 2. You want to compare between diet 1 and diet 2, right? Comma, and you for the t-test, if the variance is not equal, so you have to mention the inequality. Okay, so the analysis will be done for unequal variance. So if your from your Bartlett test just now, if they are having equal variances, so you have to tell the system that yep, the variance are equal, so it's true. T is for true. If the variance is not equal, you put it F, means that for false. So variance equal, yes, it's true. So just then semicolon and you run it. Very simple and just in less than 1 second, right? The data is diet 1 and diet 2. T equals to, this is the T value for diet 1, diet 2, degree of freedom, and the P value is 0.00508. All right. So the alternative hypothesis true difference in mean and is not equal to 0. So this is our default call from the R. So these are 95% confident interval is from 0.59 blah point something to 3.1325. This is two-tailed t-test, right? So the point on the left, right, on the rejection region on the left, the point there is actually 0.5921. And on the right, rejection region at the point of start of the 3. So that is the 95% confident interval, right? So these are also the mean of X, mean of Y, right? So you can have that from this t-test, okay? So, and that's it. It's very easy. And for the, yeah. Let's go to, I just want to ask you a few questions. Okay, that is question number 1. So for the question number 2, all right, you will be using this data. What you need to do is that you have to prepare the Excel data file for this experiment. Okay, you have to prepare the data first in Excel file, or later you can okay, save your data file. You will be calling this file. Okay. This is from the practical 3. You already done this, right? You already done this. This is data. You have the data. Let me go to this practical. Okay, problem 2. Use the data that you have saved in practical 3. All right, what is the statistical test that you should be using? Okay, so what is this the statistical test? You have two groups, all right? So that obviously it is t-test, all right? So is it an independent sample t-test or paired t-test? What do you think? Anyone? This data, you have 10 areas and you have 2 methods, all right? In each of these areas, 1 to 10, you will put in container, 2 containers, one for method A, another one with method B. And for all the areas in this lake, I guess, you have 10 areas. Each of the areas will have 2 containers that contain shrimp for method A and shrimp for method B. So will you use independent sample t-test or paired t-test for this?
Paired t-test.
Yes, paired t-test, because you are using the same area for both method A and method B, right? The area 1, area 2, area 3. So the same area for each of this is pair A and B. All right, so paired t-test. So you will state your statistical hypothesis to be tested, and then you test it. And let me show my data for this before Q2. Yep. This is my data matrix. I have 3 variables there. All right. I have areas, and then I have method A and I have method B. Why it looks like that? Because each of these areas will have those 2 methods, right? So there are 3 variables there. So I saved this already. All right. Let me show you what, and let me import the data just to show you in a just to show you what's happened. Okay, so I call the data first. I use the name is data Q2. Okay, just run it. I have data Q2 already, and then I attach it again. Attach. All right, so I have to check the data. I use Bartlett test again. Okay, this is one way of doing it also. All right, you have to put in another name. Let's say my dad. I just use my dad or my data. Also, it's okay. And then you want to tell. Actually, I imported the data, the Excel data, right? So I have to tell R what is the data frame looks like. So I have in that my data frame, the important one is just method A and method B. Okay, so I give a name for this. Okay, so then I want to run Bartlett test. I call Bartlett test and put in the in parentheses the my dad. My dad is the name that I would give for this data frame, right? So run it. For the Bartlett test, homogeneity of variances, it passed because the p-value is 0.2, right? They are homogeneous. The variance are equal, right? So, and then I run the t-test. So again, the function name is t-test. It's the same. And I'm testing method A and method B. Yes, and I did mention this is a pad t-test. With the pad equals to t means that true. So we have two type of t-test, right? Independent t-test and also pad t-test. So this is if you have any problem with this function, let's say t-test, if I'm not mistaken, help, yep. We want to ask about t-test. You just type in t-test, help t-test, right? The help will come over here, over the plot area, right? You enter this. Hey, shoot. I'm sorry. Ayo. Now I don't know how to stop this. Is it F5? Come on. Okay. Let's put this. And then another this. Okay. Sorry for that. Help the test. Enter. Right? So the manual or instruction about the t-test will appear on this console in this area, right? It's students t-test, how to use that, the name is t-test, parenthesis, blah 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 inside there. So the argument that you want to put in here in these parentheses, you have to put in the data that you want to use, all right? The x, the y, and if necessary, all right, if necessary, like you want to tell this is a pad t-test, okay, there's pair, you have to put it pair equal to true, variance equal, is it equal or not when you use Bartlett just now, right? So it's equal, so you put a T. So anything else, if you want to ask about the test that you are using, whether you want to use help in R, help whatever it is, or you can always Google. Okay, you will find the answer. So yeah, run there, and method A and method B, degree of freedom, p-value is 0.0047. So what is your decision if you have this result for your t-test? What is your decision for the hypothesis testing? Anyone?
Reject null.
Reject null hypothesis, right? Because the p-value is less than 0.05. Very good. So, oh, it's 9:41 already. Okay, I leave it to you to try it. Okay, and I'm not going to give you this script. I mean, this my code. I can give it to you later, but not now. I want you to try it first. Very easy, because I give the code in your question paper. I give you both for SAS command. Okay, SAS is the same. So you have to type in all this, and then you will get the test. For the R, you type in this, put in the data. I also teach you how to put it manually if you want. And also remember the importing tools using the environment windows. All right, three ways of importing your data. You just follow any of these, you can do it. Yeah, and then these are the instruction. This is for checking the data for normality. This is the code, and you want to test for variance equality. This is the code and the t-test. Okay, and also this is an example for PET t-test. This is actually for question number 2. Okay, all of the above are the same, goes for question number 2, except for the t-test, right? You import the data, you do the normality testing, variance equality testing, and then you do the t-test for question number 2. The steps are the same, right? So you can just follow for question number 1, similar to question number 2, except for the t-test. The t-test a bit different. This is when you are using PET t-test, so you have to put in the PET function here. PET equals to T. T means it's true. This is a PET t-test. All right. So, any question? I know that. Yeah, I'm sorry. What was that?
For the data from in the Excel,
Mhm.
can it be more than one sheets in that one Excel? Can we use the Excel if there are more than one sheets?
Yes, you can. But I cannot remember the exact code. If you want to put in there is folders in there, right? So which folder that you are using, you can try to Google it, how to put in to call the specific folder for specific data in that Excel file, or else just copy that folder into one new Excel file and name that Excel file and use that file. All right, because I cannot remember. You can always Google how to use Excel file that are having multiple folder in there, right? So how to call the specific folder that you want to use. Yes, you can Google that. I'm sorry, I cannot remember that, and I don't intend to remember all this code. I usually just Google it. But there's two ways. You copy that data, put in new Excel file that will only have one folder in there, or you can always try to find a way of a correct code to use to call for the specific folder in the Excel file. Alright?
Alright, Doctor. Thank you.
You're welcome. Any other question? Semua orang dah isi attendance list? Copy this again. Okay, that's the attendance list. Tak semua orang kot. Ada yang belum bubur lagi attendance. Okay, please do so. And kalau tak ada apa-apa soalan, I leave it to you untuk try. Kalau siapa yang ada dekat farm sekarang ni, nanti balik boleh cuba. Please cuba beritahu juga orang lain yang tak datang kelas hari ni, tolong cuba buat pakai RStudio tu. Or else kalau you tak buat, you will learn nothing. You kena buat. Okay. Memang susah sikit mula-mula. Kita tak boleh nak faham apa benda, macam mana nak ubah kod dan command tu. Tak apa, you try, you buat dulu, and then macam kita mula-mula nak bercakap zaman masa kita kecil-kecil macam itu juga. Mungkin kita tak sedar lagi lah. Macam mula-mula you datang UPM, nak belajar naik bas UPM. It's very easy for you now, right? Tapi zaman mula-mula your first day, first year in UPM, mesti you takut macam mana nak naik bas UPM ni. Same thing. You have to do it. Buat, nanti benda tu akan menjadi macam di hujung jari je you buat. Lagi banyak you buat, lagi cepat dan lagi senang you faham. Okay. So for this course, I really appreciate if you, bukan appreciate lah, you wajib lah, you kena buat RStudio ni sendiri. Try, you can discuss, tapi you kena buat juga. Alright. Kenapa saya cakap macam ni? Sebab saya tahu anytime you boleh je copy kawan-kawan punya kan. Dapat je. Tapi please don't do that. Cuba buat sendiri, you boleh discuss, you boleh apa semua, tapi try buat sendiri. For your own sake. Nanti I rasa you rugi kalau you tak buat, then you learn nothing. Okay. Sebab nak meniru senang je. Tak ada, saya tak boleh check, saya pun tak tahu you buat ke tak buat. Bila hantar report nanti, okay, everything is there, all the command and kalau you tiru pun boleh juga buat macam tu. But it's not good for you. Tak baik dan awak rugilah. Nak masuk UPM susah juga. Tapi kalau you tak belajar, dua kali susah lah. Right? So I'm not accusing anything. I really know that this class semua dah mature dan pandai. Okay. So pandai, jadilah pandai dalam cara yang betul untuk yang elok. Jangan pandai nak kelentong, nanti akan jadi politician nanti one day. Karena you pandai tapi you pandai kelentong je. So pandai yang bijaksana lah ya. So buat benda ni senang je. Nanti bila you dah buat, dah few times you buat, you gonna be okay. Nanti next practical, next week I'm not around. Okay, I'll give you another practical question and I will record the lecture. I put it in Putra Blast. And kalau ada apa-apa soalan, you can always contact me through WhatsApp or through email. Okay, I will get back to you kalau I'm not available that time as soon as possible. And try to discuss dengan your classmate also. Nak solvekan. Mungkin ada orang yang ada some computer programming background. Yang tu lagi baik. Mungkin dia senang sikit nak explain. Dia cepat nak explain. Ataupun always Professor Google is around kan. So boleh sentiasa tengok lah. Kalau apa-apa soalan, jawapan yang perlukan. Okay. So ada apa-apa soalan? Semua orang dah over attendance? I think so. Ada 21 orang. Is it? Yep, ada 21 orang. Okay, kalau tak ada apa-apa soalan, I'll stop here. Okay, so you can continue.